So we have, let's say, a beam like that, and there is a force of 80 newtons acting here at making 40 degrees with the vertical, and there is a force of again 80 newtons 80 newtons 80 acting at that point, making an angle of 25 degrees with the vertical, and then let's say there is a vertical force of 250 newtons acting there, and this distance is 3 meters, and this again is 3 meters, and this is 4 meters, let's say. Okay, so now we have a beam on which there are 3 forces acting, and let's add a couple to it. Let's say there is a couple of 100 Newton meter. A couple of 100 Newton meter also acting on it. Okay, so now if we look at, now we are supposed to replace the force system. First question is replace the forces and couple acting on the beam by a force couple acting at the base of the beam. So we need to find an equivalent system where the beam is still there, and then you have a single force and a couple acting at the base of the beam instead of this many forces and couples. Okay, so the only condition in this case is your sigma F, sum of all the forces and sum of all the moments about the same point. Let's say this point is O, the base is O, moments about O in both the systems should be the same. Okay, so let us look at sigma fx first. What do we have here? You have vector form 80, the first force, this force 80 sine 40 degree I cap plus cos 40 degree j cap. Let us take this off. We need to add all the forces, plus you have the second force, this one 80 sine 25 degree I cap minus cos 25 degree j cap, because the y component is downwards. Second force is done, and then you have plus 250 j cap, that force upwards, this force upwards, and then so this is the total force. So sigma F, if you do the whole thing, this will be 85.23 I cap plus 238.8 j cap. So this is the net force, and net moments about O is R, So 250 times 3, this is K cap positive, right? Because 250 newtons is causing a counterclockwise moment about O, and then you have minus 100 Newton meter K cap, and then you have minus 80 cos 25 degree times 6, and then we have plus 80 cos 40 degree times total 10. 3 plus 4, 10. This is the net moment. So if you do, so this is K cap, this is, everything is K cap, K cap, K cap. Okay, so the total moment, so the net moment acting on the system is 827.81 Newton meter. K cap positive. Okay, so now you need to replace the force and couple acting on the beam by a force couple acting at the base of the beam. So for A part of the question, you have the net force. Force is whatever this is, R, let's call this R. So your R is acting like that. It has an X component of 85.23 and Y component of 238.8. So 85 and 238, so it is more like that. Okay, so this is your R vector, and then you have a moment M of 827.81 Newton meter. Fine. So what is the B part of the question? It says find a single resultant force acting on the beam that can replace the given forces and couple. Okay, so now you have to reduce this even further to a single force. How is that possible? You can, your total force, this sum of all the forces should always be equal to your R, and moments about O should always be equal to 827.81. Okay, so all we can do is move the resultant force to some other place. So let's say we move it there, R. Now sum of all the forces is still R, right? X and Y components will be the same. Now the moment will be whatever this distance is, we have moved it by, let's say, X. So the moment about O will be X times Ry, which is this, and this must be equal to 827.81 Newton meter. So we know Ry, which is 238.8. So from this we can compute X to be roughly 3.5 meters. So this whole system of forces can be replaced by a single resultant, which is acting at a distance of 3.5 from O. That is a force of 20 newtons okay, a force of 20 newtons acting at an angle of 30 degrees, and this is O, A, O, B, and okay. So find same, whatever, find equivalent force couple at O. Determine a single resultant force acting at a point along OB. Okay, so we have this triangular plate, and there is a force of 20 newtons acting at point A on this triangular plate OAB. Okay, we need to find equivalent force couple at O. Same process. What is sigma F? Sum of all the forces acting on the system. 20 sine 20 sine 30 I cap plus 20 cos 30 j cap. This is the total force, and all the moments about O is OA cross F, right? 20 cos, 20 sine 30 degree I cap plus 20 cos 30 degree j cap. So okay, this is, let's say, 40 mm. So this is 40 OA, 40 cos 20 degree I cap plus 40 sine 20 degree j cap cross 20 sine 30 degree I cap plus 20 cos 30 degree j cap. Okay, so if you do this, you get 800 cos 20 cos 30 minus 800 sine 20 sine 30. So your total moment about O is equal to 800 cos 50 degree, which is 514.23 Newton meter. So this is the net force and couple at O, or couple or moment that can replace this force acting at A. Okay, so you can have, so that is done. This is part A. B is determine a single resultant force acting at a point along OB, right, which is equivalent to whatever the resultant of the existing force couple system. Same process. So you have like that, and then this is OB. Net force is 20 sine 30, 20 cos 30 acting at O and a moment. So now you have to move that force to somewhere there. So there will be Fx and Fy. Fx, which is 20 sine 30, and Fy, which is 20 cos 30, or the resultant, right? Okay. So now it is acting at a distance of x. Moment about O will be x times Fy, and this must be equal to your 514.23. So this will give your x as 29.7 mm, roughly 3 centimeters. So you have here your resultant will be 20 newtons acting at 30 degrees at a distance of 29.7 mm from O. So you can move this force to from this point A to this point on OB, and still the system is equivalent, right? Let's say there is a body like that, and then this is O, this is A, and you have Newton force acting there, and then you have 50 Newton force acting there, and you have 20 Newton force acting there at an angle of, let's say, 40 degrees, and there is also a couple of 30 Newton meter acting there. Okay, and we have distances. That is a point, that is a point, that is a point, that is a point. Okay, let's say this is point A, this is point B, this is point C, and this is point D. Okay, point D is at a height of 0.2. Point C is at a height of 0.4 meters, and this is 0.6 meters. Total height is 0.5 meters, and this whole thing is 1 meter, let's say. These are all the forces, and these are the distances of various points. Now we need to find the resultant. Find resultant. Find resultant, meaning single force which can replace the whole, all three forces and the couple. Okay, and its x-intercept from O. So this is our O. All right. Okay. So let us do sum of all the forces. What do we have? Minus 60 and 0, and we have 50, 0, and we have minus 20 cos 40 degree and plus 20 sine 40 degree, right? This force, this 20 Newton force. Okay, so sum of all the forces is equal to, this will be 25.32 and minus 25.32 and 12.86 if I am not wrong, newtons. Okay. Now that will be the resultant force. Now your moment should help, moment about O is minus 30 Newton meter, that one, minus 50 times 0.2 about O, 50, point D is at a height of 0.2, and plus 60 times 0.5, okay, and plus 20 sine 40 degree times 0.4. 20 sine 40 is vertically upwards, and it is at a height distance from O. From O, this is O. From O, this distance is 0.4, and it is upwards, so it is causing counterclockwise, which is positive moment. Okay, then plus 20 cos 40 degree also at a height of 0.4, right? This height is 0.4 here. Okay, so all of this will come out to be 1.27 Newton meter. Okay, so we have the total moment. So if all of these forces and the couple has to be replaced, that can be replaced by force F minus 25 and 12. Okay, almost X is almost double the Y. Something like that. So this will be the resultant acting at O, and then you have a moment, positive moment of 1.27 Newton meter. Now you need to find a single resultant, so this moment should also be provided by this force, right? Okay, so and x intercept, so you have to move it along x, so then this should be converted to x intercept, so this has to be at a distance of x, and this will be r. So about O, moment will be, O will be, you know, not in it, but arrow. Okay, about O, the moment will be x times r y. So this is 1.27 equals to x times 12.86. So your x will be roughly 0.1 meter. Okay. So if we were to find the y-intercept, if we were asked to find the y-intercept in this case, then we will have moment is 1.27 Newton meter. So our force is minus 25.32 and 12.86 newtons, and moment is 1.27 Newton meter. So if we were to find the y-intercept instead of x-intercept, so your resultant is something like that. This is the F and M. So if we were to find the y-intercept, so the point should be, the force should be acting somewhere there, and moment about O, right? Moment about O will be 1.27, which will be equal to Fx times y, right? Because your y component Fy will be passing through the origin and will not be providing any moment. So this will be 1.27 equals to minus 25.32 times y. So y will be equal to 0.05 meters. This is x, y and z axis. This is my origin. Okay. So there is, let us say 20 Newton force acting along that length, and 50 newtons acting there, and 50 newtons acting there, and 50 newtons there, and then 40 newtons and 40 newton there, and then let's say we have a couple so in 3D this is how the couple is indicated, 30 Newton meter. So it is acting about z axis, negative downwards, right? Okay. And then you have, let's say, a couple about 175 Newton meter about x-axis, and then you have one more couple of 20 Newton meter along y-axis or about y-axis. Okay, so now, and the dimensions, this is 6 meters and this is 2 meters cuboid. This is 4 meters. 4 everywhere. Okay. Same. Find the equivalent. Find equivalent force couple system at O origin and find single resultant force acting on the bottom XY plane, somewhere on the bottom XY plane of the block. Okay, so that is what we need to find. Let us do sigma sum of all the forces. Same process. So sum of all the forces will be 40 and 40 cancels out, 50 50 50 cancels out, so you have only two remaining, which is 20 I cap minus 50 k cap, right? And all the moments, this is going to take a sum of all the moments about O. You have 175 I cap. First let's get all the couples, plus 20 j cap minus 30 k cap minus 40 times 4, 40, these two together, 40 times 4, right? This and this together causes 40 times 4 minus j cap, right? These both of them together are causing a negative moment about j axis, plus 50 times 2 k cap, and lastly we have moments due to these two, 50 or 50 newtons r cross f. Always first r is 2 I cap plus 6 j cap plus 4 k cap cross minus 50 k cap, plus you have one more, which is 6 j cap plus 4 k cap, which is O to that point, right? 6 j cap and 4 k cap, 6 j cap and 4 k cap. Okay, cross 20 I cap, right? So if you do all the cross product and everything, what we get is minus 125 I cap plus 40 j cap minus 50 k cap. So that is the sum of all the moments. So this is the moment and this is the force which will be acting, force acting at O, moment about the 3 axis, right? About O, which is equivalent to all of these. We can replace all of these forces and couples with these two, this and this. Okay, now you need to find a single resultant force acting on the bottom XY plane. So let us try doing that. So let's say again, so what is it? What do we have? We have F, the resultant force F is 20 I cap minus 50 k cap acting at O, and the resultant moment is minus 125 I cap plus 40 j cap minus 50 k cap. Okay. the moment should be equal to, so acting at some point on the plane, so your R will be Rx I cap plus Ry j cap. Since it is in the bottom xy plane, there is no z component, so this moment should be equal to R cross F, right? Rx I cap plus Ry j cap cross cross 20 I cap minus 50 k cap. So this will be 50 Rx j cap minus 20 Ry k cap minus 50 Ry I cap. This must be equal to this. This should be equal to this. So that means minus 50 Ry, which is this, should be equal to minus 125, and 50 Rx, which is that, should be equal to 40, and minus 20 Ry should be equal to 50 Ry should be equal to this minus 50. This will give Rx equals to 0.8 meters and Ry equals to 2.5 meters. That will be the point. So 0.8, 2.50 will be the R at which this force F must be acting. That will be the resultant of the whole set of forces and couples acting on the cuboid. Okay.